So hello to everybody. So now we will have this practical part of the course, which is based on a couple of softwares that we are installing now. Arduino IDE, the processing and KiCad, plus the sources of the codes for these development environments. Then we have this Arduino kit. Let's say any kit is good, but this one is a little bit special because I've modified it a little bit in order to accommodate it for this course. So now I'm unboxing it. So I'm just opening the box. So on top of this box you will find a couple of tools. So there is this is a plastic tweezer. It's not really full plastic. I mean, this black plastic usually is so-called anti-static plastic. So it has something inside, I don't know what exactly, but it's a little bit conductive, not that much, but enough in order to deplete static charges that can accumulate on insulator-like plastic things. And this is good because when you want to touch electronic components, something like this one, for instance, this is a little printed circuit board, or PCB as an abbreviation. So if you want to touch it like this, what you don't want to do is to deliver electric discharges that you can accumulate. For instance, if you are wearing a wool sweater and then you remove it, and then when this thing will touch your hair, it can accumulate charges, and usually you can, if you then touch something which is connected to the ground, to the earth, so like a piece of metal connected to the wall or whatever, then you will feel an electric shock. If this shock will hit a circuit, it will very probably destroy it. So we have to avoid the static discharges like this. And those things are useful when they are made with this conductive plastic, because it will not allow to accumulate charges on it. I mean, not easily, let's say. Then there is another thing. So there is a battery here. Maybe we will not need it, but it's better to have it. Then there is this little bag with a couple of things. So these are patch electrodes. So those patch electrodes are there in order to be applied on the skin, like this. So we'll do this later on in this course. So you will disconnect it from this pad like this, and then it's like a piece of let's say scotch tape, so we can attach it to the skin safely. Then you have a sort of mixing tool. It's just a plastic stick, and this will be used in order to use these two tubes. So one is filled with water, so simple tap water, and then the other one is filled with this greenish substance, which is a conductive gel. So more specifically, it's this one, signal gel. So it's an electrolyte gel, so basically a kind of salty solution. And this is used when you want to have an electrode to be in contact with the skin. So this conductive gel will fill all the gaps you can have because of the structure of the skin or whatever. And so it will create a good electrical contact between the electrodes and the skin. So this gel is already embedded in the electrode. You see this greenish stuff, there is a little sponge. But it might happen that this thing is dry. So we will see later that by just adding a drop of water and maybe a drop of this electrolyte gel, we can recover an old electrode. So those electrodes are disposable, but they can be recycled a couple of times. And they are disposable from the point of view of the hygienic reasons. So don't share electrodes between multiple persons. So then what we have here in this box, so we open this. There are many things here. So here you have a box with a USB cable, which will be used to connect the Arduino. So this is the box with the Arduino board. Then you have another box with jumper wires, another box with electronic components, and besides the original components, I've added a couple of new components that will be used in this course. So more specifically, I added this microchip here. You should be able to find it. So it's TL084. It's an operational amplifier, actually 4 of them. So this case here is again made on this conductive plastic, and you see the pins of this microchip, because they are inside this case. So if I push it from this side here, now I do something that I should not do, it like touching this with my hands, but I do it. So all these legs are short-circuited with this. So because they are short-circuited, they have the same electric potential, so it's not possible they have a difference of potential, and so they will be protected. So voltage cannot build up between one pin and the other one if they are all shorted together. So you see, most of the time in electronics, it's good practice to handle the things from a side like this. And for, let's say, the purpose of explanation, I do this, which I should try not to do, like touching the components like this. This is bad. So let's try to handle the components like this. Similarly, if you have a circuit board, it's better if you hold it like this from the edges, not like this, because then you will touch the components, but always from the side, like this. Okay, so then another thing you will find in this kit is something which is called the breadboard. Now I have a big one here, which is easier to see. So this thing is for prototyping. So just to give you an idea, for instance, this is a microchip. I just put it here. So carefully I can put the legs of the components, so the terminals, inside the holes, something like this. You see? And once you have it like this, carefully but firmly, you can push it inside, and then you can verify that it's connected at both sides. So if you want to remove, you can go like this with a tool. You see underneath it, and a little bit from one side and from the other one. You can lift it carefully without bending the pins too much, and then you can disconnect it and reconnect it as many times as you want. So this board is made for fitting components having this pitch from the one pin to another one, which is 2.54 millimeters, which is basically a tenth of an inch. So in electronics there is this strange unit for measuring distances. They are called mils, which are the millesimal part of an inch. So it's a mixed metric and imperial unit for unknown historical reasons. So the distance between one of this hole and another one in this unit is 100 mils, which is 2.54 millimeters. So maybe you have already met the breadboard in other courses, but just to make a short introduction. So inside these holes there are sort of metallic clips that can handle the pins, the metallic pins that you insert in it, and they can create contacts. So the contacts are arranged this way. So every column of 5 holes are all connected together. So this column, this column, this column, this column. The columns are independent, but all the holes, 5 holes in a column, are short-circuited. So this is useful in order to create bridges, so to connect many things together. While the upper 2 rows and also lower 2 rows, they are usually all of them connected together, one row. So for instance here I have one row which is labeled with the letter W and X. So all the W holes are connected together, all the X holes are connected together, but the W's and the X are not connected together, and similarly the other ones. Sometimes, depending on the breadboard and also on the size of the breadboard, there can be a break in this connection in the middle. So it might be that all these holes are connected together, then there is a separation, and then again all those holes are connected together. It depends on the breadboard, but most of the time it's like this. What you have here in this kit is just half of this breadboard, so it's like this. So the microchips, like this one, are supposed to be placed in the center, because then you can take advantage of these 2 sets of holes. So one for the, let's say, lower part of the microchip, and one for the upper part. If you put it like this, of course, it's not good, because then the lower part will be short circuit with the upper part one by one, because of these 5 holes which are connected together in each column. Okay, so this is the breadboard. Then what you can put in the breadboard are also other components. So you have the wires like this, small and big ones. Then here we have other components. So the most popular and easy component is the resistor. So here we have a set of resistors. So they sometimes come connected with these 2 paper stripes. So if you just pull it like this, you can disconnect one, and then here you have it. So the body of the resistor is quite small. The terminals can be bent like this, for instance, in case you need. And then carefully with your hands you can insert them wherever you want, something like this. You just push it gently. I hope you can see this. And so for instance, if I want to connect one resistor with another one in series, just take another one, I bend it like this, I put it here, okay, and now those two ones are connected in series because of the column which starts at the number 31 in this breadboard. They share the same 5 holes which are all short circuit together, so those ones are in series. If I do like this, now they are in parallel. And just to be confident with the layout, if I do it like this, I just move the one terminal of the resistor on the right up by one hole. So now they are apparently in parallel, but in reality they are in series, because this hole here is not connected with this one. So okay, you see, they are in series because they are connected because of this connection. So we have to be a little bit careful in doing this kind of things. Then, speaking about the resistor, there is this guy here. This is a sort of resistor, it's called trimmer. So it's like this. The one you have in your kit has been modified by me, and it looks like this one. So I mounted it on a small PCB, this thing which is here, because I've noticed that with the breadboard you have this type of pins here cannot enter the hole very well. If you try to push them, then you break the thing here. So now you have this, which are much better for this breadboard. So what it is they are two resistors connected in series. The common point is this central pin here, which is called the slider or the cursor, and this is moved by this hole here, where you can find also a knob mounted. So if you rotate it, you can change the value of one of the two resistors connected in series to it, and then also you can change the value of the other one in a complementary way. Then what we have it will be used in this course is a capacitor here. So this is a so-called electrolytic capacitor, which are the type of capacitor which are good when you want to use a high capacitance. So this is a 50 volts 10 microfarad capacitor. So it means that the capacitance is 10 microfarad, and this 50 volt is the maximum voltage that this guy can withstand if you apply voltage to its terminals. So now it's safe for our circuits because we will not use more than 5 or 9 volts, so we cannot destroy this capacitor. Then you have plenty of other components, LEDs, whatever. So this is a kind of big transistor. Then there is another couple of things in this kit. I don't think we will use it. So you have an LCD, an LCD panel. So a small dot matrix display like this one. So this thing again has this array of pins that can be easily used to insert it on the breadboard. And then also there is another box with a DC motor and a servo motor that probably we will not use in this course, because this course is mostly tailored in order to understand the amplifiers which are of interest in, for instance, for neuroscience applications. Okay. And then there is the multimeter also, this thing, this tool, which is very useful in order to measure a couple of things. So there are these two leads, so, and 3 holes here. The black one goes in the middle one, which is usually called COM, which stands for common. And this corresponds to our 0 voltage terminal, what is called the ground also. Then you have other 2 places where you can put the other one. So this one is the one that is used in order to measure voltages, resistances, so the ohm symbol. Then you can check diodes. There is this little symbol of a loudspeaker, which means that this thing will beep, is the continuity tester. And then you can also use it in order to measure currents in the range of microamperes and milliamperes. But if you switch to this one, then you can use this tool in order to measure currents in the range of 10 amperes. So here, in basically every multimeter, there is a sort of indication like this one. So this symbol is the symbol of a fuse, and here it tells you the maximum current that this thing can withstand. So if you put more than 200 milliamperes current flowing between this terminal and that terminal, then the fuse will blow, similarly to this one, but with 10 amperes. So we have to be careful. If we are planning to measure a current of 5 amperes, we can't use this because the protection will blow, and then it's difficult because we have to open the device, the multimeter, and replace the fuse. So most of the times we will use it in order to measure voltages and resistances. So if you turn it on like this, there is also a button for the light, so you can better see. So here you have a dial knob you can use in order to change the range. So these numbers are the maximum voltage that you can measure. So it gives you the range of the multimeter. So you see, if I move it, the position of the dot will change it according to the scale. Then if I move it like this, now this thing is not measuring voltage anymore, it's measuring resistance. Now this strange indication is an indication that is telling us that this thing is not measuring anything, because we are not connecting any resistor between the common and this terminal. So if I do it like this, now I can try to measure the resistance of something. Like for instance the resistors I attached, sorry, on the breadboard. And let's do it the proper way. So I put the multimeter here, then I take the breadboard. Let's see if I can destroy the screen of my iPad. I put it like this. Now I bend it a little bit so you can better see. Maybe I can also zoom it. Let's see if I can zoom. Okay. So if I go here and I touch with the tip this thing and with the other tip of the terminal this, like this, I create this electric.
Excuse me?
Yes?
1 second, because we have to put the battery in the multimeter.
Ah, okay, sorry, okay.
And we need the cacciavite. Now we are going all to put the battery.
Okay, good.